All right. This example. This example wants us to do what? It wants us to use the graph of y is equal to f of x to sketch the graph of its derivative. All right, so notice what we have here. We have y is equal to f of x, a rough sketch of it drawn there. We need to sketch the graph of its derivative over here, okay? Now, we're going to make a very rough sketch of the graph. It's not going to be exact. We're kind of just estimating here, okay? All right, so let's draw the derivative. Well, where do we start? What's the derivative look like? I don't know. What do I know about derivatives, though? I know it's like the slopes of the what? Tangent line? Yeah. Let's start, say, right here at this point. That's about the point 0, 1.5, right? If I want to draw the derivative at that point, what do I really want to know here? If I want to know the derivative at this point, what do I really want to know? The slope of the tangent line at this point. Tangent line at this point is going to look something like this, right? What would you say that slope is of this line? Well, it's certainly negative, right? And we're just kind of roughly estimating this. We're going to do a rough sketch. So what is the slope? Maybe about -2. I would say maybe about -2, maybe -3. Maybe some of y'all say -1, but we're still in a ballpark somewhere. So we're saying at an x value of 0, my slope of my tangent line is -2. Or at an x value of 0, my derivative is -2. At an x value of 0, my derivative is at -2. So that's what I'm going to plot over here. What about right here? This is about 1/2, 1, that point right there. What about an x value of 1/2? What is my derivative? What's my slope of my tangent line? What's the slope of this line right here if it's horizontal? It's 0, right? So at 1/2, the slope of my tangent line is 0. So at 1/2, my derivative is at 0. At 1/2, my derivative is at 0. So I'm going to plot the point 1/2, 0 for my derivative function. How about at 1? At 1, I'm right here. And what's the slope of my tangent line at 1? Some positive value, right? Maybe like a +1. So at 1, the slope of my tangent line is at 1. Now you might have put 2 here. That would have been okay because we're guessing this anyway. How about at 1.5? At 1.5, what is the slope of my tangent line at that point? 0. So let's plot 1.5, 0. Now what about at 2 here? At 2 here, what is the slope of my tangent line? Oh, very steep, huh? Maybe it's like -3, maybe -2.5. Slope of my tangent line at 2. Maybe I'll say -2.5. At 2, I'm at -2.5. Okay, what about over here? What is that? Let's see, that was 1/2, 1, 1.5, 2, 2.5, right? At 2.5, what's the slope of my tangent line? Well, it looks even steeper, huh? Maybe -3. So 2.5, I'm at -3. So what's going on so far? What could be going on? What could be going on is I could have some kind of curve that looks something like this so far, right? Now, it's not going to be exact because really I need to take the slope of the tangent line at all these in between. Instead of just at 0.5, I would need it a 1/4, at an 1/8, at a 1/16, and so forth. But this is just a rough sketch of what it could be. On Wiley, what you're going to have to do is you're going to have to pick multiple choice. Which one could it be? All right, what about at 3? What is the slope of my tangent line? It's 0, right? So at 3, my derivative is at 0. So I'm going to plot the point 3, 0 here. How about over here at 4? At 4, what's the slope of my tangent line? I don't know, maybe a +1. So at 4, I'm at positive 1, so my graph maybe turns something like this. How about at 5? At 5, what's the slope of my tangent line? Very steep. Maybe like 3. So 5, 3. Maybe I'll draw something like that. And let's label this graph. Y is equal to f prime of x. Now keep in mind, that's just a rough sketch of the graph, okay? That's not exact by any means. But it's just to form a concept, really. Concept in your head. All right, let's move on here. Let's move on. All right, so let me ask you this. Let's look at this example. It says sketch the slope of the tangent lines at x is equal to c. Slope of tan lines at x is equal to c. They want you to sketch the slope of the tangent lines at x is equal to c. Then they give you a graph for part A. Part A, they give you a graph and they say, okay, here's c, and your graph does something like this. Go ahead and call that, I guess, an X and a Y. Let's sketch. When it says sketch the slope of the tangent line, it really should be like sketch the tangent line here. Let's see, well, what does your tangent line look like? If I were to ask you what's the tangent line at this point, it wouldn't be any trouble. You'd just sketch something that look like that. But what about at C? Does my tangent line look like that at C? Does it 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 look like that at C? It's not clearly defined, is it? So, I don't know. How about B? What if I have a graph that does something like this? Draw my axes here. Let me call that C. And what if I have a graph that does something like that? At C right here, wouldn't the slope of my tangent line, or wouldn't my tangent line, look something like that? What do you know about that line? It's a what kind of line? Vertical. What do you know about a slope of a vertical line? It's undefined. All right, so we're going to say this. 2 common ways in which a function that is continuous at x naught can fail to be differentiable at x naught are corner points, so at corner points, and points of vertical tangency, okay? Here we have a vertical tangent line. Here we have a corner point. So at both of those, corner points and vertical tangency, are 2 cases of where your derivative can be undefined. All right, so let's do our next example. Our next example reads, where is the function y is equal to the absolute value of x minus 1, not differentiable? Well, what is this? You learned in pre-calculus algebra, that's the absolute value function shifted to the right 1 unit. So you learned in pre-calculus algebra, the way you graph this is you say, okay, here's 1, 0, and my graph's going to look like this and this, right? So where is that derivative undefined? Well, at a corner point, right? And where's my corner point at? At x is equal to 1 right there. So where is it not differentiable? At x is equal to 1. All right, up till now, we've been saying, okay, this means the derivative of f with respect to x. There's other notations that we use for derivative too. We're going to use this one quite a bit in this class. The derivative with respect to x of f of x. So instead of reading it as d over dx, we usually read it as the derivative with respect to x of f of x. You're also going to see this, the derivative with respect to x of y. The derivative with respect to x of y. which a lot of time we end up rewriting this as dy over dx. All right. We're also going to see this. If y is a function of x, or y is a function and we're taking a derivative with respect to x, we're going to see y prime for the derivative. And one that we see every now and then, we don't see a whole lot in this book, is the derivative with respect to x looks like this. Capital D subscript of x of f of x, like that. All those mean derivative. You're going to see some of them in this book. Some of them you will not see in this book, but your teacher next semester may use them. So I want y'all to be familiar with them.